psychédélique un peu. Okay, so yeah, I'm gonna talk basically about installing software and creating modules on Compute Canada servers. So by the way, Compute Canada is now called Digital Research Alliance of Canada. But yeah, I'm just gonna stick with Compute Canada because it's shorter. I'm not a fan of long names. So I'm going to start by talking a bit about who I am. So I'm a computer analyst. So that's the actual title of my job. Although I do mostly bioinformatics stuff at the Montreal Clinical Research Institute. So I work for a bunch of labs and the proteomic platform. So the proteomic platform, the actual name is Mass Spectrometry and Proteomic Platform with Denis Faubert. I'm working also with the Transnational Proteomics Research Unit with Benoit Coulombe. And that's who recruited me in 2004. So a few years ago. And I also work in the Chromatin and Genomic Expression Research Unit with François Robert. So what I do is I analyze some proteomic and genetic samples. I also create some databases to store experimental data. And normally it's accessible through a web browser. I also program a bunch of custom software because I have a bachelor degree in computer science. So here I put a few of the GitHub links of what I'm doing. So as you can guess, there's obviously the GitHub for the IRCM. Also maintain the proteomics platform server. So basically it's just a Linux server on which a bunch of different softwares are running, and one of them is Mascot that they use almost permanently. Also create some websites. So a few years ago, Benoit asked me basically a simple question that seemed dumb at first, which was, is it possible to run MaxQuant on Compute Canada servers? So why MaxQuant? That's because we use that in proteomics, and it consumes a huge amount of resources. So another question was, is it possible to make it easy for like any biologist to run MaxQuant on Compute Canada? So that was some pretty interesting questions, and that got me started to where I am today. So this presentation. So a few disclosures. So first of all, I'm going to show what I did to run different softwares on Compute Canada. Softwares that are not like already installed there. But unfortunately, I'm not an expert. So maybe someone from Compute Canada would have a better solution. I'm not also going to use Easy Build. They use that on Compute Canada. So sometimes your software might be available on Easy Build, so you might want to look at this. The modules I'm going to show are, well, it's based on the best I could find based on the Lmod documentation. So it could probably be better, but another note is that some modules will load their requirements. In general, the modules on Compute Canada don't do that, but I'm just doing it so that biologists don't have to all load a whole bunch of modules that are requirement for the modules that they actually want to use. You could also use Singularity in some cases to make things easier, but anyway, I'm going to show you why it's not always easier to use Singularity. And as a side note, I will patch some Python scripts during the presentation, and I'll explain why I'm doing this. So it's kind of a special case. So So what are modules? So modules are used on Compute Canada. So it's basically to make any software available on a path. So for example, if you just connect to Compute Canada on one server and you try to type in some tools, that's not gonna work. You need to load the module before the program is available. A good thing about modules is that it allows you to use a specific version. So you can do a bunch of analysis and always make sure that you use the same version of the software. A fun fact is that modules can be installed basically anywhere. The only requirement is that you need to set an environment variable for Lmod so that it's able to figure out where your modules are. And well, obviously, there's a whole bunch of modules available already on Compute Canada. So this is the link to the documentation. So I might change the pointer to. Yeah, usually there's a the possibility to have a red dot, but I'm not finding it. So what I suggest is that you put your custom modules inside the projects folder, so it is available for everyone in your lab. So obviously the softwares also will be installed in the projects folder. So why using MaxQuant as an example? So it's for several reasons, but one of them is that it's easy to install. It's just one zip file. You unzip it and that's it. MaxQuant only has one requirement, which is mono. So at least it has one requirement. So that makes it possible to show you a bit how you can use requirements. MaxQuant is widely used in proteomics experiments, but I'm still going to show an example for something else, just if you're curious. And I'm also use some Python and Bash scripts around MaxQuant just to make it a bit easier to use. So what MaxQuant does basically is it's just a program that matches some peptides with some MSMS spectra. And the MSMS spectra, they are obtained from an MSMS machine, and they are saved inside a raw file in general. So here's the link to MaxQuant, and this is the link to like the Python and Bash scripts. So let's start with something that we can do. So if you have a terminal and access to a Compute Canada account, then you can type SSH with whatever server you like to use. So in my case, I'm going to use Bilga. So just type Bilga Compute Canada.ca. So I'm connected there. After that, you just CD to whatever project you want to use. And so in my case, that's just going to be the Coulomb lab. Then you make whatever directory you wish for. So then just CD into that directory. And then you just, just copy this long link. So I'm going to reduce that a bit just to be able to copy this.
Could you share it on the chat?
Yeah, that's. I'm going to try to do this.
Thank you.
Open chat. Okay. So if someone can send that also on YouTube, that would be a plus.
Yes, I will do it.
I'm just cloning the modules from Benoit Coulomb's lab. And then I just cd into the modules directory. So I can wait a few minutes just to be sure that if anyone else wants to try that, they can do it. So I took an example. So I did type Narval. It's mostly because that's the newest server. Unfortunately for me, I already installed MaxQuant there, and some of my coworkers are using it, so I cannot just delete that. So I had to use another server for it to work. So if everybody's done, then the next step, basically, because just doing that will not make the modules will not become available. So let's say I type module spider MaxQuant. That's not gonna work. Oops. MaxQuant. So as you can imagine, that's not going to do anything. Although the modules themselves are present in the MaxQuant directory. So that's all the LUA files that you see there. So to make them available, you need to run this configure script. So just type in /configure .sh. So once you do that, once you do it, you need to either source the bash profile, your bash profile file, or just disconnect and reconnect. In my case, if I source the bash profile, it's just going to screw up my terminal because I'm using oh my bash. So I'm just going to exit and go back on Beluga. So that, once it's done, if I do a spider MaxQuant, then it should be able to find the different modules for MaxQuant. So as you can see, then right now they're already available. So that's a nice thing. Another thing you might want to do is that I created a script that's called email sbatch. So to run it, just type email sbatch with your email address. What this script is going to do is that it's going to add an alias in the bash profile, in your bash profile file, so that if you type sbatch on the terminal, it will replace sbatch with sbatch mail type nfl with mail user with whatever you typed in. The reason you might want to do that is that it's going to allow you to receive an email in the event of either your program completing or failing. Obviously, that's completely optional, but you always can do that. If you want to undo the configure script, you just need to type configure.sh with clean as a parameter, and it's going to remove the modifications that were done. Later on, if someone from your lab wants to run use any of those modules, they just need to run the configure script once, and they're good to go. Well, as you can guess, we did install the modules, but we didn't actually install MaxQuant. So we need to install it. So here are the comments that you need to run. So I'm just going to cd back inside the projects directory. inside the modules and type basically the MaxQuant. Well, I can type that easily. So just slash that MaxQuant / install. And we're going to install the version 2.0.1.0. So once I do this, it's going to install MaxQuant. So basically just it's going to download the zip file. It's going to unzip it. And if it's available, it's also going to download the Singularity container. And I can explain why using Singularity for MaxQuant might be useful. But that's I'm going to do that later on if there's still time. After installing MaxQuant, we're also going to install the Macron Tools. I'm just going to do that / Macron Tools and install. And this time I don't really need to specify a version number because it's just going to take the, in this case, it's the most recent version. And you're going to learn a bit why it's not actually required or it doesn't have to. So this script normally takes a bit more time than installing MaxQuant. Among the main reason being that it's going to install a few dependencies, like one of them being PyAML and Click and other things like that. Good. So now that it's done, we can load the MaxQuant module. So just load MaxQuant 2.0.1.0. Once it's done, you can test if you can run stuff. So you can type MaxQuant with it's a dash that it dash help, and that's the help file. The other thing you can do is show the help file from the MaxQuant software itself, because that's actually the help from the Python script. So you can type mono with this specific executable, and that's going to show you the help from the MaxQuant software itself. So it shows that it's working. So here is what you can do to test MaxQuant with real data. So we're not going to do that right now, but the presentation is going to be available, so you can just type all the comments there. The only thing I'm going to specify is that if you don't run the email SBash script, rather than just type in MaxQuant, you're going to need to type MaxQuant -- mail with whatever email address. So what did I just do now? So basically, I just cloned the Benoit Coulomb's modules from GitHub, and I added the modules directory to the path that is searched by Lmod. So that allows you to type module and load whatever modules that were just installed. Also installed MaxQuant and the Macron Tools using the installation scripts. So I'll explain a bit more in details what all of those things are. And I'll explain it a bit with the source code. So something that I also did in there that might not have been obvious is that I've patched some Python scripts. And what I mean by that is when you install some Python softwares, there might be executables that are installed at the same time. So those are executables, but unfortunately, there are some scripts files with a shebang at the start, and the shebang is going to contain an absolute path. So in general, so on Compute Canada, it's going to start with /home/ your username. So in my case, that's Poitras. Then whatever, and you get Python.exe. I wrote Python.exe. That's on Windows, but that would be just Python for Linux. So this is not going to work for other people. That's just going to give permission denied. So that's not going to work. You could patch it up with the real path. That, for example, on setter, that would be /project/ with some number. Unfortunately, that's not going to work if the actual path is changing at some point for any reason. And it's not going to work if you want to copy that on another Compute Canada server. So another thing I found on the internet would be to patch it by replacing with the user bin environment executable. So if you do that and you specify Python, that's going to work in most cases. Unfortunately, if you load several modules that have Python that's declared, unfortunately, the Python that's going to be loaded is not the one from the virtual environment in which you're installing whatever software that you actually want to use. So in this case, it's just going to fail, and you might spend a bit of time figuring out what's going wrong. So what I did is that I just created a bash script that will fix the shebang at the beginning of the Python scripts. So those shebangs will use actually an environment variable from which it will extract the path to the virtual environment in which you installed whatever Python software that you wanted to use. So obviously it might not work for you, but I've made it as general as I could. So what the patch does, it's going to create a wrapper that will find the Python executable from the virtual environment. And it's going to replace all the shebang from the executables to call the wrapper. So since the path is going to be read from an environment variable, it's going to work for every user, and it's going to work on other Compute Canada servers. So that's pretty much it. Another thing that you might want to know is that if you install some R software and Python software, if they install some system libraries, you probably will need to patch them using a script that was made by Compute Canada experts. So it's called setrpaths.sh. And I I'm giving you the link to the documentation to be able to run that. And another thing is that I included a link to how to install R libraries on Compute Canada, because you're not going to be able to install R libraries out of nowhere. You need to install them on a directory on which you have a write access, which is not the case with the default directory that will be available if you load an R module. So here are the references to Lmod and Singularity if you're interested in those. And I'm going to show you a bit of source code. So I'm going to start with the configure script. So just to show you a bit what it does. So that's just the cleaning part at the beginning. So it's not really that interesting. So one thing it's going to do is that it's going to add to your bash profile reference to load this specific file that's going to be created later. And this file is basically going to contain the code that will allow to load the modules. So here I'm just getting the relative path to the project folder. So it might seem like a huge amount of code, but it's doing something really simple in the end. And after that, it's just going to create the apps add-on file. So the code there that's interesting is just that it's going to add some, it will use this line of code. So it's going to do a module use with whatever directory the modules are located in. And that's going to be a relative path. So it's going to work. So it's going to be relative to your own directory. So it's going to be like something like /home/poitras/project/def. Well, in this case, def Coulomb /apps/modules. So it's going to search the modules there. So that file is obviously written in the apps add-on that was added in the bash profile. So that might seem a bit complex, but once it's done, you don't need to care that much about it. What you need to care about is how to create the modules file. So module files will always look like this one. So there's an help at the beginning where you can write whatever you want. After that, you usually use some what is. So that's some metadata information in which you can put the version and a few information about keywords, description, a few things like that. In this case, this is a requirement to use the module. So it's gonna, so the module will not load unless you load the standard environment from 2020, which is the default one that's automatically loaded for you once you connect to Compute Canada. So right now, this requirement is filled. The only reason it wouldn't work is if you load another standard environment. The depends on is a function in Lmod that will load the module that you specify. So it could be a requirement, but just to make it easier, I'm using depends on. So when you load the MaxQuant module, it's going to load Mono. It's going to load Singularity. It's going to load Python, although that's absolutely optional. That's not an actual requirement. It used to be a long time ago. That's the only reason it's still there. And it's going to depend on the Macron Tools module too. So here it's going to set a few environment variables. So to be able to set them, I'm going to get the module path to begin with. So the module path will looks like this. So the module name will look like MaxQuant 2010. So these are functions that are already defined in Lmod. So you can just call them. So the module base directory, I'm interested in getting it. So it's based on the module path, with I subtract this portion. So that's just going to give me the location to the apps, the modules directory. And I'm trying to get the location of the apps folder, which is the parent of it. After that, I'm gonna.
You just start.
Live stream is on.
Yeah. So the next thing is the home directory of the app that's going to be installed. So that's the apps based, to which I'm appending the name of the modules. So that's going to give me the apps/MaxQuant with whatever version. So that's the location where MaxQuant is going to be installed. So I want to save that home variable. So I'm going to set that into the MaxQuant environment variable. And I'm going to also save the version of MaxQuant. And that version is obtained using my module version there. So that's 2.0.1.0. So that's going to be useful for the installation script. So here's the installation script. So if you're not used to a bash script, so that's the shebang at the beginning. So it just tells Linux to use bash to run this script. So set -e is just to make it stop if there's any error. So basically, I'm just going to source the few comments function that I'm going to use later on. So the version is going to be whatever first parameter is passed to the script, if there is one. So this is optional. And here it's a function that will just validate that this specific version of MaxQuant exists. So if the version is empty, it's going to check for a file that's called .module.rc.lwa, which defines a default version. So if the module exists, then it's just going to purge any module that were already loaded. It's going to load the modules that are required to install MaxQuant. Then it's going to just delete the MaxQuant directory and recreate it to make sure that you have a clean install. So it's going to cd into that directory, and it's going to download from the internet the file that's called MaxQuant with the version that we want to install. So that's a zip file. If you wonder what that thing is, that URL that comes from GenApp. So if you don't know what GenApp is, I suggest you have a look. It's a nice thing that guys from Compute Canada did. So among other things, it allows you to share some files. So that allows me to download the zip file from MaxQuant from a data hub that I already created. So since it's a zip file, I just unzip it, then remove the file that I just downloaded. And this is to download the Singularity container, which is a SIF file. So I download it from the same data hub. And since the file might not be available, this piece of code will just, it's just there, so it won't fail if the file is not available there. So here's another module. So that's for the Macron Tools. So as usual, you have a help section, a bunch of what is. So this is that's not an actual requirement. It used to be the case, but that's not true. Mostly because of the patch that I explained for the Python script. So the same. So these variables are exactly the same as they were for MaxQuant. So in this case, obviously, it's going to be the MaxQuant tools information that's going to be there. So what I'm using here is a prepend path. So you can use that to add a path-like variable to a path-like environment variable. So it's going to add to the path environment variable a bash directory that's inside the home folder. So the reason I want to do that, that's because inside the bash scripts, there are scripts to allow you to run MaxQuant using sbatch, the sbatch command. So that's the normal way you run jobs on the Compute Canada server. You use sbatch with whatever bash script. In addition to that, I add to the path the virtual environment. So that allows me to run, for example, the MaxQuant executable, which is there. And that may change also the default Python or npip that is going to be used. So obviously, I'm going to set the same environmental variables as I did with MaxQuant, except that I'm going to call them, obviously, Macron Tools, because I don't want to use the same name. So it's going to be Macron Tools and Macron Tools version. So here's the installation script. So the beginning is exactly the same as for MaxQuant, except the modules there, they're going to be a bit different. Since it's using Python, obviously Python is going to be loaded. So it's going to clean the directory. In this case, the code is on GitHub, so it's going to clone the directory, the GitHub code. And the reason it's doing it is because otherwise I wouldn't be able to copy the bash scripts. And it's going to check out whatever version you're trying to install. It's going to create a virtual environment for Python. And it's going to install the software using pip. And obviously the Git file that was just downloaded. I'm also going to use a wrapper. And as I said, that's to batch the Python scripts. So the wrapper is going to have a long name. And that's just so that it's not going to collide with another wrapper from another software. So I'm going to call this function that was defined in the comments function. I can show you what it does, but it's just going to write the wrapper file using this as the path to Python. So in there, so it's going to use the Macron Tools environment variable. And after that, I'm going to fix the Python shebang for any executables in that directory. And it's going to be the name of the wrapper that's going to be used for the shebang. Another thing that it's going to do is that since there are some bash scripts that are using sbatch, there's an account parameter that looks like this. So you get this pound sign with sbatch, then you get an account definition. So I'm going to get the project name based on the content. So basically, it's the name of whatever is under the project's folder. So in my case, that's going to be def Coulomb. So that's the name of the account. So I want to change whatever sbatch account that was present in those bash script files with the actual account that's going to be used. Because if you don't modify them, the default account that it's going to use will be, in this case, it's going to be the Coulomb lab. And obviously, you don't have permissions to run stuff under Coulomb's lab unless you're a member of my own lab. So obviously, I have to replace them. So it's going to be done automatically for you. You don't really need to care about that. So that's the a bit difficult portion. So here is an example of the bash script that's used, that you could call directly with sbatch. So as you can see, there's a bunch of sbatch information about, for example, the account, the amount of time, the amount of time that you want this script to run, if you want to send mails, and the output, where is it saved, and the only command that is run is this one. And so obviously it's going to run mono and the MaxQuant command.exe executable from MaxQuant. And this is just to pass any additional parameters that were already present. So that's a usual bash script that you invoke with sbatch. So that's basically how you can run MaxQuant. So it might seem a bit complex, but in the end, all of this, I try to make it as easy as possible so that you wouldn't really need to care that much about that code. So if you're curious about program software that you might have a higher chance of using, so this is how to install MultiQC on Compute Canada. So this is the module file. So basically, as usual, you have a help file, a help section at the beginning, a bunch of what is. The same as you would get anywhere, except that I defined the version there, but it's basically the same because it's just calling that function that's already available. It's got prepend to the path, the virtual environment, because MultiQC is programmed in Python. So it's going to set the same environmental variables as you would expect, an variable for MultiQC and version. And the installation script is as easy as the other ones. So the beginning is exactly the same. There's I'm loading Python at some point because it's a requirement. I'm cleaning the MultiQC directory, and then I'm just installing MultiQC using pip, and I'm going to install whatever version was specified, and I'm fixing the shebang so that it's going to work. And once you did that, you can just type MultiQC once the module is loaded, and it's going to work. So that's pretty much the nice things here. And if you're interested in knowing how to use Singularity, sad to do this with MaxQuant, because in MaxQuant I had to replace some configuration files that are installed in MaxQuant by MaxQuant. Unfortunately, modifying those files is not an option because you don't want to modify a program that's installed into a common directory that's used by everybody. So using Singularity will allow me to do that. So this is something that looks like a Singularity container definition. Since there's a whole bunch of red and it's difficult to read, I'm going to open it here. Unfortunately, the definition file for Singularity will not look like this. So if you have if you want to install something else, probably it's not going to look like this. The only line that's important is this one. So I'm defining a MaxQuant version there. So right now the version is fixed, but I would like to use that script to install any version or to create a container for any version of MaxQuant. So I have a script that will create the Singularity container, and that's located and it's available inside the modules that you cloned before. So basically, it's just going to make sure you're running as root, because to create a Singularity container, you must have Linux installed and you must have root access on that computer. So it can be a virtual environment. Yeah. Another thing is that it's going to make sure that you specify a version number. After that, it's just going to copy the the MaxQuant definition script into a new file, and it's going to change the MaxQuant version of that script. So that the MaxQuant version is set to whatever you specified. So that's going to create a temporary definition file, and it's going to call the singularity build on that to create the container. So that's not too difficult. The only thing that's difficult is to create that definition file. So that's pretty much it. So I showed pretty much everything that I wanted to show. So another thing that I'm going to show is just to give you an idea of what the patched script Python executables look like. So I'm going to go inside the Macron Tools folder and the bin here. If I check the head of, for example, MaxQuant, so it's using, so the shebang at the beginning here is just going to use the env program to figure out the location of the wrapper. And the wrapper itself is 3 lines of code. So it's just going to load the Python executable from the Macron Tools environment variable. So that's the path to the Python executable. That's located inside this directory. So it's that Python executable is there. And it's going to run that Python with whatever parameters that were specified. And if I do ls -l here, you're going to see that Python 3 is actually just a symbolic link to the Python that's installed on directory from Compute Canada. And that's what happens when you create a virtual environment. So that's pretty much it. Does anyone have any question? Maybe.
Thank you, Christian, for your presentation. It was very straightforward and interesting. I have a question about the modules, and I'm wondering if we can install any software that we want that is not available on Compute Canada through your pipeline on the config.sh, and just put the software itself. And on the depends on, I see that there is depends on that you call the software. So wondering if we can just use your pipeline as architecture and plug any software on it.
Yes, you can pretty much use anything. I've installed so much different softwares. It's if you're curious a bit, you can check the modules that are installed that I installed from François Robert. So you go to the GitHub of François Robert's lab, and you go to the modules
Nice.
GitHub project, and you're going to see there that there's a lot of softwares in there. There's, like, for example, Cut Adapt, that is, for some reason, isn't available by default on Compute Canada. I'm not sure why, but there are a bunch of things that are that I added there. Obviously, so what I presented is, so the configuration script is going to work. So just copy that and just don't care too much about it. You can just change the name of the file that's written so that it's going to use another name. So you won't have a collision with. So if, for example, I have several labs, so since I'm installing modules in different project folders, obviously those add-on files, they have different names. Otherwise, it wouldn't work. So just after you've done that, just create a new directory for whatever software you want to install. So that directory should have the name of the software you're installing. So it should be, for example, cut-adapt for cut-adapt software. Then you create a file that is the name of the file should be the version number. Then you add the .lua as an extension. Then you just copy whatever module that I created before, and you change just the help file at the beginning, the what is section, and at the very end, you change the name of the environment variables. And if you need to add some information, some directories to the path, you just add some prepend path functions. So it shouldn't be difficult. What's going to be very difficult to program is the installation script. So I did several of them, but if you're not an expert of bash scripts, it might be difficult for you to create an installation script, but you can also just do one in Python if you prefer. It's going to work. I use just bash script because bash is already present on Linux. So that's the only motivation behind the fact that I wrote it that way. It wasn't easy at first. I had to look up a bunch of Stack Overflow discussions to put that together. So yeah, I did bang my head on a few walls a few times. But now it's working, and I'm just copying whatever I did before, and I'm just adapting the end. So if I know that I'm installing something in Python, I just copy from the script from another Python software, and I just modify a few lines where I need to do it, and that's it.
Nice. That's perfect. Good to know. I'll use it if I use Computer Canada one time, because I'm not using it on my work currently, but will be very useful if I'll use it one day.
Yeah, I'm using that intensively now to analyze a bunch of data, and that allows me to I'm like Francois contacts me at some point and he says I have 18 samples from ChipSeek or whatever, and 2 days later I'm giving him all the results.
Cool.
That's how fast it is on when you run stuff on Compute Canada. It's kind of crazy.
And depends on the queue too. I do remember this too.
And obviously, I have some bash scripts that will do the analysis. So to make it a bit easier, on Compute Canada, normally you want to use some arrays of servers as much as possible. But unfortunately, when you use arrays, the only information you have about what you're supposed to be executing on that specific array is the index of the array. So what I did was to create a Python script that would read. So when Francois sends me a bunch of files, so I create just a samples.txt file, and that file contains the name of all the samples. So I download the FASTQ for all those samples. The FASTQ files are renamed to match the name of the samples. So after that, from the array, the thing that I'm doing is that I have an index of the sample that I'm actually analyzing. So each server in that array is going to analyze one sample. So everything is going to run in parallel at the same time. So I don't care if I have 200 samples. They're all going to run at the same time on the servers. And the cool thing about the arrays is that they can run in any order at any time. So as soon as one server is available, it's going to start one of your jobs. So that allows me to be very highly parallel. That's also something that's done through the GenApp pipeline, GenPipes. That's the actual name if you're...
Genome Center.
So they also did a good some pretty good work on gen pipes. The only thing that is a bit problematic for me is that usually they ask me for some strange analyses that are not covered by gen pipes. So often I cannot use exactly the pipeline that they suggest by default.
That's cool. Perfect. So we finish. If we don't have another question, going to finish right now the meetup. Thanks again, Christian, for the presentation. It was very interesting. And if you wanted to present on MonBUG, please let us know. We are looking for speakers for the next year.
And also, if you have any questions about this, whatever I presented, but you might have questions later on if you try to install the modules, for example. I can just type in my email address. It's already in the presentation, but just contact me and ask. I'm trying to install whatever module on Compute Canada. Can you help me? There's a chance I might just give you the content of the module right away because it might just take me 5 minutes. I mean, creating the module file for multi-QC and the installation script, that took me 5 minutes.
Nice. There's a question from Pedro, and he wants your email, and he said if your slides can be available somewhere.
Yeah, I'm gonna give you the slide, Yasmin, and you can just make them available on, I don't know where, maybe MonBUG.
I'll check out if I can share it through Meetup website. Otherwise, I can send directly to Pedro your slide, and if someone are interested in the slides, I can share it with them.
Yeah.
But he's looking also for your email address.
Good. I forgot to show you the last slide with the thank you, but I guess that's not really that important.
That's okay.
It's basically just a thank you with a meme under it.
That's perfect. That's okay. Great. So if we don't have questions, we close the meetup of the October, and see you very soon. Thanks again.
Thank you. See you.
See you. Bye.
Merci beaucoup.
Merci.